Hi everyone, welcome to my talk on NativeScript, an open source framework for building cross-platform mobile applications. A little bit about me, my name is Sebastian Witalec, and I work as a technical evangelist for Telerik by day, and by night I'm NativeScript superhero. I engage with various dev communities around London, such as the International Developers Group, and here I mean you guys. I also work with a software architecture mentorship group, and I run the NativeScript Insiders group in London. Today I am going to talk a little bit about the mobile OS landscape. I am going to highlight some of the core issues of cross-platform development, and then I'll give you an introduction to the birth of the NativeScript, and we're going to have a small, deep dive actually into NativeScript architecture and how it actually works from inside. And then at the end, I'm going to reveal our plans for the future. So prepare to be amazed. OK, so let's start with a quick overview of the mobile platform Django. So as it is right now, iOS and Android continue to dominate developers' choice. Android has much bigger audience, while iOS is much easier to monetize. Therefore, it's very easy to actually forget that there's a third player in the game. And Microsoft has been recapturing quite successfully its lost ground. And as according to one of the surveys, basically about 28% of developers claim that they are now developing for Windows Phone 2. Right? And supporting all of those platforms will give you an almost complete coverage of the smartphone market share. But the coverage by itself is not going to pay your bills. This is why it's actually important to look at how many apps are there available in the stores and how much money is going on around in those marketplaces. And what's interesting from this graph here, you can see that Windows 4 has 4 times less apps than in App Store or Play Store. However, its total revenue is only 20% less than what we see with Play Store. Interesting, right? So what does this mean to an individual mobile developer? Well, it gives you a huge opportunity to earn between $3,500 and $5,000 a month if you develop for any of those platforms. However, if you develop for all of them, you could double or triple that amount quite easily. And as expected, a lot of mobile developers already recognize this opportunity, and they're developing for multiple platforms. However, this number has shrunk in the last couple of years, from 2.9 targeted platforms on average over a year ago to 2.5 9 months ago, and to 2.2 as of the latest report. And if we exclude game developers, then this figure is as low as 1.75. You see, cross-platform mobile development is a little bit like a three-way chess game. I bet you didn't even know this existed. Yeah? It's very much like a three-way chess game, except you make all the moves. You get a whole much bigger board to conquer. However, the game complexity increases, and you have to analyze each of your moves from yet another angle. Often you will find yourself in complex and unpredictable situations which will take quite a lot of effort to resolve. Yet, I still wish that cross-platform mobile development was as easy as a three-way chess game, because at least each of those pieces behave in a predictable pattern. You know that this one can only go one piece forward or two. However, mobile platform APIs, they don't behave in a predictable pattern. And this creates us a problem where you have to build and maintain multiple versions of the same applications trying to solve the same problem. Bugs reported on one platform may exist on the others, but remain unnoticed. Apps that are meant to behave exactly the same across different platforms may exhibit subtle differences due to differing implementations. And one of the big challenges as well is shipping new features at the same time is really, really hard. And why is this so difficult? Well, if I'm to develop for Android, I need to learn Java. I need to install Android SDK and set it up with Eclipse. For iOS, I need to use Objective-C, and install Xcode and have to develop on Mac OS X. And then finally, for Windows Phone, I have to be using XAML with C#. I need to set up all the packages and install Visual Studio on Windows 8. If I'm to develop for each of those platforms, building native applications, I have to use multiple machines. I have to learn multiple languages, and I have to become expert in all those platform APIs. This is far from being optimal and far from being easy. On the other hand, we have another option, which is with Cordova hybrid mobile development, where with HTML, CSS, and JavaScript, you can target multiple platforms in one go. However, this comes at a cost. You have to sacrifice the beautiful and smooth user experience that we grew accustomed to. I mean, don't get me wrong, in actually quite a lot of situations, you can build quite amazing and very functional applications. But in some scenarios, this is just not good enough. So this is why we decided to create a cross-platform framework for building native applications using native user experience that you can deploy to most devices and platforms. We envision a framework that will allow you to build applications with just JavaScript and access native APIs and native UI controls. Think of it like a single code to build for multiple platforms, for multiple native platforms. So what's the first point of call? What should we do first? Well, come up with a killer project name. So we came up with Kempo.js, Natural.js, Universal.js, Native.js. But we are really after something much more than just a JavaScript library. Then Crossfly, Crossfire, and Crosscompile crossed our minds, but we decided to cross it out. After that, we considered Conjoin, J2SN, ScriptBridge, and ScriptGap. And each of them, they have interesting ring to them, but it's just not good enough, seriously. We seriously considered Xcompile as one of our main candidates, but we kept looking on. So without any further ado, I introduce you to NativeScript, a framework that allows you to build native apps with just good old JavaScript. You get full stack of the native user experience and no excuses. And now it's time for a demo. It's not over yet. Don't go anywhere. So what I am going to do is this is getting interesting. Just give me a moment. I need to plug my phone so that I will run all the applications directly from my phone, and you'll be able to see it on the screen. Because I'm using a Samsung phone, Samsung has actually quite this very useful tool called SideSync, which allows you to actually connect via USB cable and show it what's on your phone directly. So please don't text me now. Tweeting is fine. I can accept tweeting. So what we've got here on the left. Oh, this is going to get confusing. Cool. So on this side, I'm using App Builder IDE for building native applications. I'll zoom in. OK. Why can I not zoom in here? Zoom in the window. OK, let me just swap them, because I can zoom in here, probably.
Are you able to enlarge the fonts a bit?
Not in this one. Let me see. Yeah, I can zoom in code. Cool. So what we've got here, let me start with. Let me just set it up nicely, and I'll get on with it. No, that's not what I need. I actually need to see my screen in front of me. Sorry. OK. We'll sort it out. Fine. I'll just sit sideways and I'll be coding sideways. That should work. Just need to see what I'm doing. Usually helps. Okay, so basically what we have, let me explain you a little bit about the structure. So this is what we start with. We have an app folder where your JavaScript code goes. Then we have some additional app resources for icons and splash screens that can be used from within your application. And TNS modules is a library of pre-built features that you can actually use out of the box that help you with your mobile development. I'll explain more about that later when we come back to my slides, so just bear with me. So in this example, we usually start with app.js that is like a starting point where most of the code gets executed. So in this case, what I'm doing is I'm using JavaScript code and say, okay, the main module that I want to display when the app starts, it's in app views hello world view. And if I go here, why can I not do that? I'll open it. We have this XML code, and this is all you need to do to build a hello world application. So the approach we took, we went for XAML, which is basically just XML, and you say, okay, I want a page. You open the page tag. Inside, you can add a label tag with text saying hello world. No HTML. There's no HTML at all. So one of the big differences of NativeScript versus Cordova, this is not running a web view. This is actually using XAML and JavaScript to build the actual native components. So the app remains native throughout the whole process. So once I have this, what I can do now is go to build, and I am going to use, in this case, a companion app for Android that we have. You can download it from any store. Just don't do it necessarily now. And I'm going to switch on my phone. And what I have to do is basically the Telerik NativeScript app comes up with a scanner. So I can just scan this, what's over there. It actually works for iOS as well. Oh yeah, at the moment this version is for, yeah, so in order to do it on iOS, I would have to generate a separate code. Very good, yeah, good point. You see, this guy's been using these tools, and he knows what we're talking about. So, if I go back to our application, let me zoom out. Here we go. We have our Hello World application. So from the moment of creating a project to and typing those 3 lines, you could easily create yourself a hello world in like a minute or 2. It really is that much effort that it takes. But obviously, if you wanted to build a mobile app, hello world wouldn't be enough. So I prepared a few examples, and we're going to just go through them one by one, and I'll explain you a little bit about each of them. So let's take, am I going the right place? Yeah. An example where we have a sign-up form. So imagine you want to, let's say, capture everyone here. So you have a mobile application where you can type in your name, your email address, a Twitter handle. Then what we'll have a button. Let me zoom in. It'll probably help. Yeah. So yeah, again, so we have a name label for name and a text field to capture that name. Then the same thing for email, for Twitter handle, and then we have a button that will call when that the user can press to capture the details. And then just for the demo purposes, there's a label where we're going to display the result of that. So that's in our XAML side. And then on the other hand, we have the code behind, which is in JavaScript. So this is just one way of doing it, but it's not the optimal way. I'll show you the better one, so you don't have to follow this example too much. But what I'm doing here is basically say, okay, on load, when you load the page, retrieve the name text field, the email text field, Twitter handle, sign up button, result label. So I'm actually getting each of those components. And then basically what I'm doing is I take my sign up button object and I'm adding an on-click event. So on-click the first thing I do, I check, are all of the details entered? If no, throw an error. If it's successful, then say success and then print out the whole message. It's really simple. So what I can do now from my application, in order to enable that piece of code, I'm going to comment out our hello world example. So goodbye world, save. Cool, that should do it. And from here, I can just go here, go and press sync. And that should re-download the application, the latest version. And here we go, it works.
Pulling that straight off your laptop, or is that being published to some intermediary?
That's going actually online, so it's not going via. So there's two ways of doing it. I could enable from here live sync. So there's an option where I could do via cable. But in this case, I'm actually using the online published service.
Is that a bit like SoCap build sort of niche?
It is, yes. It follows a similar idea. What's interesting in here, and what happens is we use something we call compile as a service. And basically, if you want to build an iOS app and you only have a Windows machine, then the only way to do it is actually delegate it somewhere else. So we have massive servers that actually run all the possible machines that you need to build those applications. So whenever I go and build, this goes to our servers, builds it in the cloud, and then comes back to you, which is quite clever. So you don't need to have a Mac to build for iOS.
Is it free?
What is so the framework is free. The live sync actually comes together with our software. So I can show you later. It's not expensive though, believe me. It's cheap. You can ask Ricardo, he's using it. He paid for it. So, oh, not yet. No, is that how it is? So we've got Ricardo. Ricardo, email will be at neverpaid.com. And Twitter handle will be say, what? And if we sign up Ricardo, here you go, we have our message. So we kind of called our function. So that's just one of the examples. You receive an email now, Ricardo.
So the difference with, if I understand, with Windows Phone, for example, you use XAML, and
Yes.
it is mapped to WPF.
Yes.
In that case, you use XAML, but it's mapped to JavaScript.
Yeah, so overall, you mean the connection between these two files?
Yeah, the view code, XAML, XML using XAML things.
Yes, so basically what we're doing, so that's quite important actually. So you see then it follows the naming convention. So if we have a file called signupview.xml, and then we have another one, signupview.js, they're linked automatically together. So the code behind and the XML code, they're linked together. So you can access, they can access each other. Yeah?
So how much do you have to know about the XML to the native implementation? Because obviously, if you'd like PhoneGap, HTML is HTML. So you know how it's going to look and work, and you know how it's going to have to style it and all the rest of it. Does that mean you need to sort of know about how the view engines work in all native platforms to know, you know, like for instance, all those buttons are all centered, they look all Android-y, it also, you know, comes with the default styling.
So basically, you don't need to know anything at all. And so that's because NativeScript comes with the, like a special modules layer, which takes care of the abstraction. So when you say in here, oh, what are you doing? When you say in here a label, we will then translate it to the iOS version of label or text field.
How consistent does the XML end up being across all the platforms?
So basically, those are, each of those are, let's say, tags that we implement and provide.
Yeah.
So if we provided a label, then it will be completely consistent. It will be using native labels from each of those components on each of those platforms. And the consistency may vary in the sense that if by default Apple always makes the buttons much bigger than Android, then you have to play with the styling. But there is quite a lot of functionality behind it to help you to do that.
That's my biggest pain with PhoneGap and Cordova is, you know, I was sold the idea of write it once and deploy it everywhere, and that's just complete rubbish. You know, all the plugins work completely differently, even if you want to use them on every platform, so you still end up switching in your code, going, am I an Android? Do this. Am I an iOS? Do that.
So the idea is that with NativeScript you can do that, but we're trying to minimize it so that, like, so far all the applications I was building with that, I'll only use one approach. But then again, I'm not a designer that would actually play with every pixel and everything. So I don't know exactly the pains, but so far it's been working quite well for me.
In a very similar sense, Xamarin, which is obviously probably very closely competing with this, they say that their abstraction above all three is about, I think, 95% in terms of you don't have to do anything specific for each platform. Would you say this is higher, or?
So I would say it is lower at the moment because, and I'll come to that later, because we are at alpha stage. We are going to release beta in 2 weeks. So by the time we go to version 1, the official release will have much more. But at this very stage, we have like all the critical components, but we wouldn't have just all of them just yet. However, there's some special mechanisms inside that gives huge advantage over everyone else, where you could actually import any plugin or anything and then actually integrate it yourself. It's really easy to do that. But I'll actually cover that later.
With Xamarin, obviously, you get just the drag and drop for doing all the, XAML stuff. You know, so you don't have to do too much. You have to. It's another thing to learn. Is that something you're going to?
So it's a bit of a funny one, because there is a big divide amongst mobile and web developers. And I met quite a lot of the web developers that they prefer to type their code and then have snippets and then do insert code. And then there's the other part, like you said, that they just want to drag and drop and then maybe tweak and make some changes. And then it's in exactly the same situation with our team, with the NativeScript team, where half of them actually wants to do it and the other doesn't. So the half of it that wants to do it actually started implementing it. So it will be added to our builder where you'll be able to do drag and drop. But I'm not one of those people. Actually, I prefer to type a bit of code. It's just, I find it easier somehow.
There is some template that you can use just to start.
Yes, yeah. So even when you create a new application, that already comes up with a template where you have already the structure and some of the items are in there. So it's really not that hard. So next thing, let me come up with the next example. So the problem with this example is that in order to code against this XAML code, we have to know each of those IDs and we have to extract it and then like manually say, oh, update text field or do something, which is not necessarily optimal. So how many of you know about MVVM? Quite a lot. Perfect. Then basically the next thing that we have, we introduced MVVM into NativeScript. And what you can do, you can start with something as simple as just plain JavaScript object. Did I? Oh, what did I do? I know. Good. Save. So, okay. We have journey calculator, and that's a very useful tool. What we have in here, let's start with this. What we have in here, we have a very simple JavaScript object called journey info. And this has a few properties. It has distance, it has miles per gallon, and the fuel cost. And then we have a calculate function that actually goes and accesses the journey info and performs the calculations on the journey info. So it doesn't go to each of the text boxes that you'll be providing details to, but instead it actually uses the journey info. And the only thing that we have to do is when we load our view, we have to set the binding context to the journey info. So from now on, our XAML knows where to get the data from. So in our XAML now, what we can do when we have text field that is meant to take a distance, we use the handlebar notation. So you basically open bracket, say distance, close bracket. And that creates a binding between the text value of the text field and the actual distance. And the same thing goes for MPG and fuel cost. And if I run it, I saved it. Let me zoom out. I can, where are we? Sync. Should come up with a new application with a new form. Here we are. So, did anyone have to travel by car today? Anyone? How far did you have to travel?
20 miles.
20 miles. Do you know the efficiency of your car? 44. What's the current cost of petrol or whatever you're using? 110. There you go. So your journey cost you £2.27, about 11 pence per mile. And the only thing is our calculate function that I was showing you before, it uses journey info to get the data. However, in order to update our result label, we couldn't just do a binding because this JavaScript object doesn't have a way of notifying the UI about any changes that happened. So using this approach, we still had to go to the view, get the result label, and then update its text value to show it on the screen. So in order to overcome that, we came up, we added like an observable object. And that will be another example. And this observable object does something very similar to what we've seen just a moment ago, except when you make changes to any properties of the observable object, it will go and notify the UI. So at this moment, we completely break the chains, and the UI does the UI stuff and binds to our business logic of the application, but the business logic of the application never actually is aware of what's in the UI. For the business application, it's just data and sort of actions and properties that you can run on. So the easiest thing to do will probably, I'll show you the example, what comes up on the screen, and I'll show you the bindings of how it works. Here we are. So what I did, I created a game where if we press new game, we'll get numbers from 1 to 10 ordered in a random fashion. And in the middle, we get a number. And we have to guess whether it's lower or higher. And you get points for that. So if I press lower, I get point. I say higher, lower, etc. And then the way this works in the code, to make sense of it, where are we? Up, down, view, so in our JavaScript behind the code, we only mainly do just the binding. But in our XML, what we do say, I want to bind the most important probably, let's say, the button click to lower and the other one to higher. And the label that is in the middle, I want to display the current card. And what we have as well, we have an up-down view model. And that's where all the business logic of the application actually happens. So what we do, we create an observable object, and we add new attributes to it. So you remember we had current card. So here is where the value sits that we were displaying on the screen. And for buttons like go lower, where are we? So we have start new game. So that was the main button in there. We're binding directly to this function. Then we have go higher and go lower. And each of them can have as complex logic as you want, but it doesn't sit in the UI. It just sits here, which means that you could actually take this view model at any time and say, I don't want this view anymore. I want to create a completely different UI. But this, if it worked before, you don't have to redo it again. And that's what I did. I actually said, well, if I'm to make money on this game, which is, by the way, amazing. You can get into it really. Like I play it every day at least once. But in order to make money, I had to improve it a little bit. So what I did, I actually added some styling to it. And let's see if I put it in the right place. Let me save. So I created a new version of our XAML. And the main thing that I've added is this attribute, CSS class. So I have info label, and for a button is a global one. But yeah, and then we have another one that says info. And then in our CSS styles, we have this. So this is the description of how info should look. So it should use font size 30 and use this color, and on and on. And all the buttons should be vertically aligned to the center, etc. So if I refresh our game, sync, and prepare to be amazed. This game is going to rock your world if it works. All right, what do I get? Lower or higher? Come on, guys. Anyone? Lower. No. Next. Oh, come on. Keep going. Lower. Higher. Higher. Ooh. Keep going. There's three cards left. Higher. Lower. Ooh. That's probably lower. 12 points. That's not really good. That's not really good. But this is the main thing that you can do with NativeScript. So the key features is the completely native application, building completely native UI, using completely native UI components. You can do styling, and you have MVVM architecture part to help you design your application nicely. And did you have a question?
Yeah. What happens to the JavaScript? Are you compiling that down into native, or have you got some JavaScript engine?
So I'll explain that now then. So that's for the demo, and then I'll explain how this works internally very quickly. So what I probably need to do is...
Is there any specific Android version you have to use, for example 4 only, or?
I think it's from 4.2. I don't know from top of my head, to be honest.
Can you share things between
From between?
Can you share things between view models from one view model to another?
Yeah, you can do, yeah. All right, that's it for that part. Let me go back to my presentation. Okay. Does this still work? All right. So this is going to be a little bit like explaining a magic trick. So I hope it's not going to take the magic out of it. So NativeScript is not just a set of libraries, but it's more of a runtime that you can use to call native platform APIs for Android, iOS, and soon Windows Phone. It uses a pre-packaged JavaScript virtual machine. And to be precise, for Android, we're using Google's V8 JavaScript engine. And for iOS and Windows Phone, it is WebKit's JavaScript core.
What version is it?
I can tell you later, yeah. And basically the way this works, the JavaScript virtual machine interprets and executes your JavaScript calls. And with any code that actually is meant to go to the native APIs is forwarded to the metadata, which looks up the native APIs and finds corresponding methods. And then we have type conversion that takes JavaScript objects, JavaScript types, and translates them into the native types. And then on the way back, it does the reverse of translating native types into JavaScript types. And then finally, we have the call dispatcher that makes the actual call. So to visualize that, let's see an example on how would you call Android's API. So in this case, we actually go in quite low level, and this is still a JavaScript code, and what we're trying to do is open a file on Android. So the virtual machine, or in this case, the V8 JavaScript engine, evaluates our code, and then the type conversion service will take the path and will translate it to the native Java-lang string. The metadata will look up Android's API and thus finding the file constructor, and then call dispatcher will execute the call, calling the constructor, and this will result in a dual result. So what you get on Android side, we get a native java.io.file object, while on NativeScript side, we get a custom JavaScript object that serves as a proxy to our Android object. So whenever you make a call on the file proxy, that gets delegated to the actual to the actual native object. So this is the foundation of the NativeScript framework and how everything works the low level. And the obvious next step for us was to create a platform agnostic abstraction layer. And that's where the things actually get much more interesting. And we call it NativeScript modules layer. And thanks to that, you no longer have to think, oh, how do I do it on Android, on iOS, and Windows Phone? But you kind of use the modules and trust the modules that they will know the how. You just think about what is that what I'm trying to do. And what NativeScript modules layer does is that at runtime, it will translate each of those calls that you're trying to make into the lower level, to the lower level. And then using the mechanism that I explained just a moment ago, this will result in the actual native calls. So, and as an example, following on our file example, oh, there's a mistake, there should be just file. This call, when we call it using the module, will result in translation for both Android and iOS. I don't have an example for Windows Phone just yet. But the idea is that what I'm showing you now is there to resolve one of the biggest issues of cross-platform mobile development. One code to rule them all. You're probably wondering about the performance, because obviously every abstraction layer, every complexity that you're adding on top of it has to come at a cost. And we were thinking about that as well. And what we did, we built a few apps. We built them natively, purely natively, and built them with NativeScript. And surprisingly enough, we found that the performance penalty was about 10%, which is really not too bad. And for most users, it won't be even noticeable. Another thing about styling, so you've seen me before using CSS. So what we did, we actually followed the CSS guidelines, and you could actually take an existing CSS file from a web project and use it in a NativeScript project, and it will work, just like that. So we support the following selectors. So you have type, class, ID, and pseudo classes selectors. And then some of the supported styles. So obviously we have to implement each of them. There's more of them, but we don't support all of those that you have in CSS, but we're trying to add the most useful ones, and as we go, there'll be more and more of them. And then, so what happens if you use an existing CSS file with unsupported styles, like Coco Jumbo here? Well, nothing. You just get ignored until we implement it. So wait until we implement Coco Jumbo. It's going to be awesome. So our current state. At this very moment, we only allow private preview, so it's only for insiders. We only provide support for iOS and Android, so no Windows Phone at this very moment. We have a feature freeze to basically stabilize the framework and catch up on documentation. And one of the major problems we have, there's no debugging at this moment. But that doesn't have to be a problem, because in 2 weeks' time, we have a beta release where we're going to add debugging. We're going to add support for building 64-bit iOS applications and add support for native third-party plugins. What this means, if you have let's say somebody build a calendar for iOS that you really like and you would want to use, all you have to do is plug it into the project, and you can start coding against it just like that. It's really that simple. There's new documentation portal, since we were catching up on documentation. But most importantly, we're going open source. So this code, when we release beta, is going to be available on github.com/NativeScript. Just give us a couple of weeks, and it's going to be there. Because the idea is that we don't want to create yet another proprietary closed source framework, but we want to build the most amazing mobile cross-platform framework, and we want to do it with you. We want to do it with the community. So what the future holds? We're going to, in May, add support for Windows Universal. It's going to be at the preview stage, so you'll be able to start coding against it, but I wouldn't release those apps to the store just yet. We're going to add localization, which is going to be relevant to a lot of people here, where basically you'll be able to build apps with multilingual functionality in mind. And then we're going to add more of those modules, like Bluetooth and accelerometer access. If you want to get involved, you can contact Valentin Stoichev at telerik.com. We also have the insiders group that I mentioned before, so if you want to get access to the code before beta, you can join this group. Or you could join me at our London-based meetup. And there is a session, I think, on the 26th of February, and we have a one whole day hackathon on Saturday, 7th of March. So if you're interested, come and find me. And for more information, go to NativeScript.com. I think I ran out of time, so there won't be any more questions. But come and find me later. Thank you very much.